everyone, welcome to Sir Ren's math tutorial. We're learning math made easy. Alright, so today we'll be talking about a short lesson under polynomial functions, and that is end behavior of its graph using the leading coefficient test. So this is for polynomial functions, and let's consider this one as an introduction before we do the graphing of polynomial functions. Okay, so let's recall first that the polynomial function of degree n in the variable x is a function defined by p of x is equal to a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus the terms between plus a sub 1 times x plus a sub 0, which is the last term, where h of the a sub I is real and that the a sub n is not equal to 0 and n is a whole number. Here are also important things to consider. A sub n is called the leading coefficient, and this leading coefficient is found in the leading term. Alright, so a sub n times x to the n is called the dominating term, where it's also called the leading term. So the leading term is where we can find our a sub n, the leading coefficient. And then our a sub 0 is called the constant term. And if you're going to get your y-intercept, you can set p of 0 is equal to a sub 0. Alright, a constant term. Alright, let's look into these ones here. This graph here, these are graphs of polynomial functions, and I'd like to show this one to you before we will try to study the end behavior of these graphs. Now, these are examples of polynomial functions. First, constant function, linear function, quadratic function, cubic function, quartic function, quintic function, and so on. These are actually functions, polynomial functions from degree 0 up to degree 5. Now, let's have first the constant function. The constant function is called constant function because the variables are raised to 0, all raised to 0. That turns 0. So that's why what's left is a constant. So you can see an example here, f of x is equal to 5. That's a constant function, and the graph is just like this, horizontal graph. It's a line. It's a line that is passing to the y-axis only and is parallel to passes to the y-axis and is parallel to x-axis. And what about the linear function? Linear function, I think you studied this one in your grade 8. The linear function, of course, when graph, it's just a line, right? It's just a line. Now, it could be going upward or going downward from left to right, or upward from left to right. It depends with the situation, okay? And the values of the leading coefficient. Here, you can have a quadratic function. As you see, it's a parabola. This is familiar to you because you have this one in your grade 9. Okay, it's a parabola. It means it's a graph of a quadratic function, meaning the function is in degree 2. You can see an example here, quadratic. F of x is equal to x squared minus 4. Then we have here a cubic function, meaning it's in the degree 3. When we say cubic, the highest exponent is 3. We have example here, f of x is equal to x cubed plus 2x plus 1. I want you to notice that let's compare quadratic and cubic graph. Here, the parabola has only one curve. Here, cubic has already 2 curves. So it's somewhat like 3 minus 1, and this one is 2 minus 1. 2 minus 1, 1 curve. 3 minus 1, 2 curves. So you can look into the degree also, and you can identify how many curves, turning points, or the maximum minima if you are going to have it in your calculus. Alright, so what about the next? We have quartic function. Quartic function is a function which the highest exponent is 4. Okay, so we have here f of x is equal to negative 3x to the 4th plus x. That's an example. So the graph, how does it look like? You will notice that the exponent is even, I mean the power is even, as well as 2. The direction of the ends are going upwards, or the same going downwards, okay, or both are going downwards. So that's called quartic. And let's look at the turning points or the curves. Here it's a 4, so minus 3, there must be 3. 1, 2, 3, correct. So that's quartic function graph. What about the quintic function? Quintic function is a function of degree 5, where the highest exponent is 5. For example, f of x is equal to x to the 5th plus pi x to the 4th minus 3.1 x cubed plus 11. Ayan. Look at the graph. It's similar to cubic, but it has more curves. Okay, cubic has 2 curves, so it's a 5 minus 1. There must be 4 curves. 1, 2, 3, 4, correct. But look at the ends. The ends of the graph. It's in opposite directions, going down, going up. Here, going up, going down. So they are similar. So degree 3, degree 5 similar, degree 4, degree 2 similar. Okay, I'm just giving you idea the similarities of this graph. Let us now study the end behavior of the graph of the polynomial using the leading term tests. And let's take note that the end behavior of function tells us what it does as x approaches to positive infinity or negative infinity. Okay, so now let us now study the end behavior of the graphs of the polynomials, and let's start with quadratic function as part of the polynomial function, as one of the polynomial functions. Okay, so situation 1, when the leading coefficient is positive and the exponent is 2. Exponent is 2 referring to quadratic function given. Okay, and a, the leading coefficient a is positive. So if it's positive, okay, the parabola is directed upward, both of the ends. Both of the ends is directed upward. So the end behavior goes that way. While on the other hand, when the leading coefficient is negative and the exponent is 2, still the same quadratic function, but the leading coefficient a is negative, the parabola is directed downward. So the behavior is that way, going downward. Okay, that's the end behavior of the graph of quadratic function, downwards if it's negative, and if it's positive, upwards, both of the ends. I hope that's clear. Let's proceed to the next type of function, that is cubic function. Cubic function, let's try to look at the situation. Let us try to look at the situation when the leading coefficient is positive and it's already cubed, right? The exponent is 3, therefore it's a cube. But the leading coefficient is positive. Look at the difference. Alright, this one here, the direction is the right goes up, the left goes down. The right goes up, the left goes down. That if positive was the leading coefficient. What about if the leading coefficient is negative? If it's negative, this will be the end behavior. Right goes down, left goes up. Right goes down, left goes up. You can compare. Positive, it's the right that goes up. Negative, it's the left that goes up. Okay, so you can check that out. Now let's proceed to a quartic. In a quartic, as I told you, quartic, there must be already 3 curves. 1, 2, 3. Okay, 4 minus 1, 3. 1, 2, 3. 3 curves already. But then, if you can see, if the leading coefficient is positive and the exponent is 4, just like quadratic, it's even, right? So both of the ends is directed upward because it's positive. Okay, on the other hand, if it's negative, and the exponent is 4, still the same quartic function, so both of the ends continues downward, directed downward. Okay, so just to take note, okay, negative po yung leading coefficient and it's a quartic function. So my graph, the end behavior should be going downward. Okay, both of the ends. Here, if it's positive, it must go upward, both of the ends. Ayan, that's how you can check that. 4. Then, as you can see, compared to cubic has 2 curves, smooth curves. Here, for quartic, we have already 3 curves or turning points. In your calculus, you call it maximum and minimum points, right? So let's proceed to the next. What about a quintic function? Quintic, that means it's already in the fifth degree. Okay, in the fifth degree, where the highest exponent is 5. Now, when the leading term is positive, you see the end goes up in the right and the other end goes down in the left, just similar to cubic. What makes it different is that it has already four curves. 1, 2, 3, 4. Since the power is already 5, so there are 4. In cubic, you only have 2 curves, but the ends will be just the same. If positive, goes up on right and then goes down left. Here, if the leading term is negative and still the same quintic function, so the right will be the one to goes down and left will be the one to goes up. Alright, right goes down, then left goes up. So interchange for the direction. And then you will still notice that since it's a fifth degree, you will have 4 turning points or curves. 1, 2, 3, 4. Ayan. So expected that when you are to graph a polynomial function in the degree 5, it will look like this or like this, depending on whether the leading term is positive or negative. To summarize, if the leading term is odd, like 3, 5, 7, so on, and the leading coefficient is positive, the graph goes upward to the right and goes downward to the left. Alright, just like the cube, the quintic, and so on. And if the leading term is odd, like 3, 5, 7, and the leading coefficient is negative, the graph goes upward to the left, but downward to the right. So downward to the right, rise to the left. So it's opposite to letter A. So A and B are talking about polynomial functions with exponents odd exponents. Letter C and letter D are talking about exponents with even numbers. So leading term is even, like 2, 4, 6, 10, so on. Okay, while the leading coefficient is positive, so the graph goes upward to both of the sides, left and right. Okay, and if the leading term is even, 2, 4, 6, like quadratic, quartic, so on, but the leading term is negative, coefficient is negative, so the graph goes downward to both sides, left and right, just like the parabola. Okay, that's how simple it is. I hope it gives you idea and you learn something, and that when you encounter graphing polynomial functions, you already have idea what and how my graph looks like. I think that's it, and thank you so much. Again, this is Sir Ran, your teacher. Goodbye, everyone.